discussion of this is very important. So suppose say if you look at the how black holes will come, suppose say a star. So once its fuel gets over, what is the fuel there? The hydrogen. Once fuel gets over, then everything will become like a some neutron, no? Or say helium. Helium will be available. Then the stars are so massive that the gravitational attractive force, what happen will compress that particular star. The stars what happen which will be whose mass will be something great, 2 or 3 4 5 times that of the sun. Such a huge massive stars, they start collapsing under action of that the gravitational attractive force. A gravitational pressure will be created, and finally open they'll become the size of cricket ball. So they'll become super dense material, and they will become a black hole. So there what happen, the idea of the gravitational pressure will come. Means next question you can ask. So why not the moment star is formed, it will collapse? Why only it should collapse? Why it should start collapse after some time? When the when the fusion reaction occurs, there what happen, the radiation pressure. The radiation pressure will balance the gravitational pressure. Due to nuclear reaction that is undergoing there, it will generate a radial outward force that's called a radiation pressure. This radiation pressure will be balanced by the gravitational force or gravitational attractive force. As long as these two are equal, the star will not collapse. Once the fuel gets over, then no longer reaction will take place. No longer that radial outward force will be provided due to the radiation pressure. Then what happens? Only due to gravitational attractive force, the star starts collapsing and will become a black hole. So there the idea of gravitational pressure has come into picture. So that I'm going to introduce here now. We are not going to discuss anything black hole. The necessity of the necessity comes in the formation of black hole gravitational pressure. So we will have a small idea. No, I want gravitational pressure inside a solid sphere at a distance r. I think already an exam came. Find the gravitational pressure at a distance r inside a solid sphere of mass m and radius r. So this is a solid sphere. Complete solid it is. Is asking gravitational pressure at a distance smaller. How you define pressure? Force per unit area. Force per unit area is what we say pressure, no? First of all, why that force will come? Okay, you analyze. Let me have a water. Okay, let's begin like this. I'll at least start it here. One better diagram will take it. So there's a sphere is there. Let me assume a layer inside. Okay, fine. Now a thin layer we have brought it. So let this radius of this layer be smaller. The radius of this is capital R. The thickness of this layer. So let me take small x here. Thickness of this dx. This layer, will it experience any force? Will it experiences any force? Yes, no? Just the outside layer, the weight of that will act, simplest way. I don't want to put a lot of mathematics here. The weight of this part will act on this thin shell. So what I'm assuming is here like a thin shell, that one. So continuously what means there'll be a force. So here the force will be in this direction. Why do this red color arrow will come? The mass which is present outside the thin shell will try to compress it. And that compressive force per unit area will become gravitational pressure. So what all we took this is a thin shell. This everything is a solid sphere. Huh? This everything is a solid sphere where it is. Solid sphere. The thin shell is what we assumed it here. The mass which is present outside what happen, its weight will act on this thin shell, on the surface of shell, and that radial inward force per unit area will become the gravitational pressure. That we have to calculate here at a distance x. A smaller, okay, let it be x time being. No, how to get that one? So I'll get into the basic formula. Df is equal to, if you go back again, if there's a gravitational field, any mass present here, will it experience any force? Yes, it will experience a force, no? And what is that df? E into dm. If any mass present in in a gravitational field experience a force. Similarly, what happens? Shall I assume that the thin shell is present in the field? Field of what? Field of what here? No. Here, what is the field strength? How much this field strength? At a distance x, what is the field strength? You write it. E is equal to gm gmx by r cube. Can you remember this field inside the uniform gravitational field strength? Now this particular, what is dm? Mass of this. Take some color. Yeah. Now same shall I apply it. If I keep a point mass in a gravitational field, it will experience a force. What is EDM? Similarly, a thin shell of radius x and mass dm, thickness dx, is present in this field. No, this field will produce this solid sphere. So then, what is the force? Force acting on thin shell should be equal to df is equal to E into dm. This initial assumption is very important. Rest all mathematics, you see, it's over. The problem will get over here. And what is the mass of that? 4 pi x square dx is the volume of shell into density. Now look at this force. One more thing, we have to go for this force. How is x measured? How is x measured? The x is measured radially outward. No? How is this force is acting opposite? So df by dx. If you calculate the df by dx will be negative. Why do this negative sign is brought? Because as x is measured, or we'll write it df and dx are measured in opposite direction. That's all over. So like how at a distance x, that on how we measure x radially outward. And what about the df? The df force is acting like this. The df force is acting. So sir, you're not showing df. Where is the df? Yes, if you want. Not at one point. Not at one point. It will act on throughout the surface of the thin shell. Force acting on thin shell. Is it agreed? Shown by red color arrows, indicated by red color arrows. Okay, rest all. This area, what is surface area of the shell? 4 pi x squared. So the gravitational pressure df is equal to df by 4 pi x squared. Because how you define pressure? Force by area. This should be equal to how much? Gm minus rho gm r cube x into dx. So this is gravitational pressure. So minus rho gm r cube x dx. Keep it here now. Let's come for this one. Let's some very important thing is there here. What is the pressure on the surface of the solid sphere? Nobody is there outside, no, here to exert a pressure. Nobody is there to exert force at this particular point. Why the pressure at this point? Because of this particular mass of this one. Here, what is the pressure? Pressure here will be zero. The gravitational pressure on the surface should be zero because there's nobody is there outside the sphere to exert here force. Able to understand? So therefore the limit at a distance capital R or at a distance capital R, it should be pressure should be zero. At a distance small r, the pressure is C. I'll put it gravitational pressure Pg. You integrate, substitute the value of rho, you'll get the required answer. So the gravitational pressure 0 minus Pg equal to minus rho Gm r cube x square by 2 capital R small r to capital R. So this negative sign I'll adjust for this. Pg is equal to G rho m r cube 2r cube r square minus small r square. Put small r equal to capital R. I think it's justified, no? Because there's nobody is there to exert force on the surface of solid space. So therefore the gravitational pressure there will be zero. Put small r equal to 0. Put small r equal to 0. Then G rho m by 2r. There is a pressure at point O. So here it is under maximum pressure. I think it's very important to study some planets, everything. Suppose if you take the geology. All these ideas are very important. This gravitational pressure is something plays very, very important role in formation of all the metals inside the earth, no? So when we go for the mining, no, the gravitational pressure matters a lot. No? So time being, I'm just explaining with the help of the concept what we know to this extent here. So if you go for Olympiad, they mix with this with the nuclear fusion. You should be very careful.